Welcome to the amazing world of automobiles, where we explore the rich and sometimes quirky history of the machine that changed the world. Cars have got bigger, faster, safer, gone to more places, entered more races, and worn more faces as the years have rolled by. Art has become a science as designers engineer cleaner, greener, smoother and safer machines. Inventors invent, engineers engineer, and the motor car has become a fixture of our fast-moving world. In this program, we explore what the future might hold. New ideas, and old ones made new. Fresh designs, and old ones revisited. Clever technology, new materials, methods, and more benign machinery. But mostly, the future will be about making the motor car cleaner, greener, and safer. Science will reduce the impact of millions of tyre tracks on our fragile environment, for our future is the present we leave behind for the next generation. The motor car is killing us, polluting the air we breathe and burning up finite resources. There has to be a better way. Every year, millions more cars pour onto the roads and pour ever more exhaust fumes into the fragile bubble which is Earth's atmosphere. As far away as Bogota in Colombia, air polluted by traffic fumes is affecting the health and well-being of city residents, not just here on the edge of the Amazon rainforest, but around the world.
I think there is a tremendous focus on really lower carbon motoring, particularly, in the UK as elsewhere across the world. Fuel prices are rising, so there's a great concern about how to extend, if you like, the amount of money that people have, that the motorist has.
In the petroleum-based version, every step produces greenhouse gases, every step along the way.
Authorities are slowly introducing clean exhaust legislation, but such laws are hard to enforce, and they're not popular with businesses that rely on trucks and transport for their livelihood. The problem is most apparent in emerging economies, where older vehicles choke the streets and the air. It's a problem the next generation will inherit, and one they won't thank us for. It's no secret that car makers and scientists are working to find alternative energy sources. And while there are many options and quite a few working examples, the cost of making a switch from petrol to anything else is huge.
Technology is changing dramatically. It is about market share, who's got the next best mousetrap. There is a race on, and I don't think the American public and the world really knows what's going on behind the scenes in the automaker. It is a revolution.
One alternative is to make both petrol and diesel-type ethanol-based fuels from renewable resources such as vegetation. Either as a varying percentage supplement or a complete replacement, ethanol fuels are a viable alternative. One drawback is that ethanol has traditionally used food crops. So, for farmers, the choice was to grow market produce or gasoline. Now, new methods can extract ethanol from plant waste products, or vegetation not part of the human food chain. In order to be considered a biofuel, the fuel must contain over 80% renewable materials.
Well, the two big questions that any producer of biofuels and biofuel technology has to answer today really are, number one, can you compete with gasoline at the pump? And number two, will this technology have an improvement in the overall environmental impact?
Vehicles that use biofuel do require small but significant engineering changes to run efficiently.
The big advantage of E85 or ethanol over petroleum is the fact that they have the potential of being produced at very low cost. And it's the best near-term example we have of a technology that can have a significant impact on reducing greenhouse gases and really taking us off of our dependency on petroleum.
There's only a limited supply of carbon fuels, and there's an unlimited need in the world for energy.
Biofuels are just one avenue being explored. The trouble is, while the fuel is readily available and emissions aren't as bad as those from engines burning fossil fuels, there are still emissions. Alternatives involve the use of hydrogen, which burns with only water vapor coming from the tailpipe, or various ways of storing or even making electricity on board to power electric motors instead of internal combustion engines. Fuel cells use various methods to create electric power, including hydrogen. Like most big manufacturers, Nissan's also built experimental fuel cell vehicles for evaluation. The costs of these vehicles are huge, but engineers need working models to test.
Nissan has a hydrogen tank on board the vehicle which stores gaseous hydrogen. We send that down through the fuel cell system with the hydrogen delivery. We combine that with oxygen from the outside air, and the fuel cell stack produces electricity. That electricity then directly feeds the electric motor which drives the car down the road.
They allow us to do a number of unique things that we don't get from other vehicles. The first is allows us to run with zero petroleum. The vehicle uses hydrogen as a fuel. The second is we have zero emissions. So there's no emissions from the vehicle, so we basically take the vehicle out of the environmental debate altogether.
The downside, of course, is that hydrogen isn't commonly available at roadside filling stations. Capturing, storing and transporting hydrogen, the lightest element, is costly. Mostly it needs to be stored at extremely low temperatures when it's a liquid. Because it bonds so easily with other chemicals, it burns easily. It was burning hydrogen, for example, that destroyed the Hindenburg airship. Engineers have addressed the technicalities of refueling. All that's needed is the roadside infrastructure. Many car makers now have working proof-of-concept vehicles and are looking at range, reliability, and how to drive down the cost of being green. In Britain, scientists have come up with a machine that effectively separates the hydrogen and oxygen from ordinary water. Assuming it can be done cost-effectively, this could be one of the greatest scientific advances of the last 200 years. The first affordable hydrogen refueling station, in readiness for the availability of hydrogen-burning cars around the world. The idea is that homes of the future could have a small refueling station in the garage, and drivers could refuel at their leisure.
The use of hydrogen won't mean a great deal to a driver in the sense of driving the car, because it will drive just the same as a piston engine car. You won't perceive that. But the great thing is that for the first time ever, you will be able to refuel your car at home. And when you then drive it, know that you are not contributing to CO2 production as you drive.
Some hydrogen-powered vehicles are being bought at great cost by groups keen to get the hydrogen ball rolling.
We sold our first vehicles to Norway. There's a potential for additional vehicles. The state of California has just ordered our hydrogen hybrid vehicles. Individual cities have purchased them recently. We have 5 cities in California, each taking 5, and they'll each be putting in a hydrogen refueling station to fill the vehicles. So we're starting to see a network develop, and I think it's going to accelerate quite quickly over the next 2-3 years.
Electric cars look set to be the next big thing in Singapore. The small Asian country has joined a growing number of countries in the region, exploring the use of zero-emission vehicles. Several innovative companies are already offering electric vehicles as a greener alternative in urban transportation. Singapore University researchers have been developing alternatives like hydrogen fuel cell technology. But Professor Lu Wenfeng is under no illusions about the practicalities of battery-powered electric cars over fuel cells.
The technology of the fuel cell is not that advanced compared with the battery, because they started about 5, not too long compared with the battery, and there are less people working on hydrogen than the battery. And so we think battery will be next coming up, and hydrogen will follow after the batteries, electric car.
A team of engineering students built an eco-friendly urban concept car powered by a fuel cell. The single-seater uses materials like aluminium and carbon fiber to keep its weight to just 130 kilograms. From the time that Henry Ford first drove his quadricycle, it seems that petrol was the motorist's preferred fuel, replacing steam engines. But back in 1876, German Nikolaus Otto invented the 4-stroke engine, also known as the Otto cycle system. Otto intended that his invention would replace the steam engines of those years, even though his engine was primitive and inefficient. It was his partner Gottlieb Daimler and another German, Karl Benz, who would give the world increasingly reliable petrol-powered engines. Hundreds of millions of them, built all over the world and driven even further. The byproducts of burning petrol, made from oil, is polluting not just the air, but the water and the surface of the planet too. So alternatives for mass transportation are a priority. Electric cars like this Indian-built Riva are one answer in high-density urban areas, as they're clean and quiet. But a trade-off between range and the weight of the batteries needed to power them, and the need to recharge frequently, marks them down as an incomplete solution. And some critics suggest that using electric cars merely shifts the pollution from the tailpipe to the smokestacks of distant power stations. The war-torn district of the Gaza Strip isn't somewhere you'd expect to see cutting-edge technology. But true to the old saying, necessity is the mother of invention, two Palestinian electrical engineers installed 32 batteries and an electric motor into a well-worn small car. As a result of, and in spite of, a year-long fuel blockade and chronic shortages of petrol, the car was driven through the streets of Gaza City. Fayez Annan said the vehicle would be able to travel up to 200 kilometers on a single charge. 6 months in the making, this prototype conversion into Gaza's first electric car is an engineering triumph in a city starved of almost every commodity, including spare parts. Annan put the cost of the project at about $2,500, but said the price of converting a car to electric power would vary in accordance to its size. He said his motivation was merely to overcome the fuel crisis.
There is no one that does not wish for a successful project, but the purpose of it is to show the world that we are capable of creating something out of nothing. Creating something out of nothing, meaning if fuel is cut off, we have a substitute. So, every human being looks for profit, but the objective was not to create a profitable project.
Back in Bogotá, one of Latin America's most polluted cities, the authorities and industry do recognize the need to cut back the pollution being emitted by vehicles. The prototype of a small electric city car was shown to Juan Lozano, Colombia's environmental minister. The Indian-built Riva is promoted by the electricity company CAM, who bill it as an environmentally friendly vehicle to help Colombians in the battle against global warming, polluted air and rising fuel prices.
We have an environmentally friendly, competitive vehicle, which is in line with humanity's needs, reducing pollution and gases. This vehicle is a mobility solution, as well as a tool to fight against climate change. Against the fires in the mountains of Bogotá and flooding. Humanity is moving towards electric vehicles. Colombia was forced to come to this era of having electric cars, and that is what is happening today.
CAM is hoping that the $25,000 car will sell in large numbers to those who care about the environment. It can drive for 80 kilometers on a single charge, has a top speed of 80 kilometers an hour, and can accommodate 2 adults and 2 minors, or up to 230 kilograms of total weight. Even the giant American car companies have conceded that it's time to make a serious effort to protect air quality from vehicles. The Chevrolet Volt is a plug-in hybrid electric vehicle produced by General Motors. The first pre-production test car was built in June 2009, and by October, 80 Volts had been built and were being tested under various conditions.
Well, a lot of people think that automotive batteries are just like batteries you buy in a power tool. And really, automotive duty cycles, which are the requirements that the customer puts on the battery, are tougher than any other for any product in the world. Automakers have to develop these batteries from scratch to serve over 10 years or 150,000 miles.
Coming out with the Volt in the middle of this is a very important statement. It's not only we have advanced products, we have advanced technology. We said we were going to make this, we said we could do it, and here it is.
First seen in early 2007 purely as a concept car, GM soon decided to put it into production. It was a brave move and something of a U-turn. Only a few years before, GM crushed over 1,000 EV1 electric cars it had built and leased to the public.
An electrically driven vehicle is always driven by electricity, and even if you have an alternative power source like a small internal combustion engine, ethanol powered engine, basically it is creating power which is used to restore the battery. And so it's quite a sophisticated change from even a current hybrid system.
The Volt's battery can be charged by plugging the car into a domestic electrical outlet. Unlike most currently available electric hybrids, propulsion of the Volt is done only by its electric motor. With fully charged batteries, the Volt can travel up to 64 kilometers, covering the daily commute of 75% of Americans. Once the battery runs down, a small four-cylinder petrol engine starts up to recharge it. Its fuel capacity extends the Volt's range to more than 480 kilometers.
The Chevy Volt is essentially made possible by the improvements in the battery technology. Lithium-ion batteries are used right now in laptops and cell phones, and people are used to very long run times that they get out of those particular devices. What A123 has done is taken that same basic concept and developed an improved version that gives better power, safety, and life.
GM predicts that more than 80% of customers may only refuel every few months. So the engine is programmed to automatically start every 2 months to stop the petrol going stale and to keep the engine lubricated. For the record, the Toyota Prius, the world's best-selling hybrid, goes only 2 kilometers on its battery alone.
This facility, this is quite unique in terms of its capabilities to allow us to get insights into electric vehicles, which in the end are focused around batteries. We need, as a country and within GM, we need significant research and development and breakthroughs in future battery technology so that we can continue to lower the cost and make it more affordable.
The Volt can reach a governed 160 kilometers an hour. Volts sold in Germany won't be restricted and reach over 200 kilometers an hour. Not bad for an electric car.
People that make gasoline cars and people who sell gasoline don't want it to happen. And they just make too much money the old-fashioned way. There's a lot of inertia. And thankfully, consumers are saying, no, we want to see change now. Let's have it happen. And California is a perfect place. We have so much renewable energy here. The electricity is very, very clean. So we could all be driving plug-ins.
Until recently, electric cars were a feeble alternative to traditionally powered cars, but this is changing. The Tesla Roadster is popular in Southern California among the young and the wealthy. Fast enough to give a Ferrari a run for its money, it's also an electric car and produces zero emissions. Launched in 2006, the electric Roadster is one of the few commercially available electric cars today. More than 900 have been delivered, and there's a huge waiting list. More than 1,000 customers have put down deposits on $100,000 vehicles.
Once a day, at least, somebody either drives by and gives me a thumbs up or honks their horn. I've had people pull me over. I had a cop pull me over to see the car to talk about it. I thought I was getting pulled over for a ticket, but I was actually getting pulled over to talk about the car. So here in Southern California, where a lot of things originate and a lot of trends start, the car is extremely popular. I mean, more popular than a Ferrari or a Lamborghini, and obviously much better for the planet.
Celebrities including Governor Arnold Schwarzenegger, George Clooney and Dustin Hoffman now all drive Tesla Roadsters.
Southern California, Los Angeles in particular, is the largest single market for Tesla Motors for the electric car. And the reason for that is we're a city filled with progressive thinkers, early adopters that are environmentally conscious, but also very image conscious. They don't want to, we don't want to feel like we're sacrificing our image for the environment. And so the Tesla Roadster fits perfectly with that image. Essentially, it's an image enhancer.
The car's powered by a massive lithium-ion battery composed of 6,800 individual cells. Weighing about 1,000 pounds, it takes up most of the car's rear half. The Roadster has earned acclaim for its exceptional design and performance efficiency. After a 4-hour charge, the car has a range of 350 kilometers.
In the power electronics module in Tesla vehicles, in the Tesla Roadster, we actually have the charger on board in the car. So essentially, you can charge the car with an extension cord that plugs into either a normal socket like you would charge your cell phone with, or what's called a high power connector that you have installed in your home to charge the car quickly.
British sports car maker Lotus helped with chassis development, and the Roadster has some parts commonality with the Lotus Elise. Tesla's body panels use molded carbon fiber composite to cut weight. This choice makes the Tesla one of the least expensive cars with an entirely carbon fiber skin. In 2009, the company opened showrooms in London, Munich, Monaco, and began taking orders from Canadians. Whatever the future holds for Tesla, the Roadster offers a glimpse of what's on the horizon for an industry that's increasingly electric.
We started in our own backyard in the US. Right now our key focus is on launching in Europe. Not too far behind that you'll see Asia, starting with Japan, and really Canada, right near us. Long term the company plans to be a global company, so you should see us anywhere in the world. I mean, there's a lot of demand in the Middle East as well.
I think the electric car is coming to Singapore, and then with technology coming in, the cost should be lower. But in the next 2 years, I'm not sure, because I don't see that the cost is going to coming down in the next 2 years. So I think the companies, I think the major challenge is that I think is the commercialization process.
BMW crept carefully onto the electric car stage with a limited run of electric Minis. It uses a 150 kilowatt electric motor tied to a newly developed high-power 380-volt lithium-ion battery, which can be recharged using a 110-volt electrical outlet. BMW offers a special high-amp wall-mounted device that will allow a full charge of the battery in less than 3 hours. The Mini E has a cruising range of 240 kilometers, well beyond the needs of most commuters. Mini E also has a top speed of 150 kilometers an hour. It accelerates from zero better than virtually all small cars on the road. The Mini E also has regenerative braking and modified air conditioning to cut down power use. The downside is that the car's rear seats are sacrificed to house the battery pack. Back in progressive Singapore, there are limited places where electric vehicles can be recharged, such as this scooter bay in a retail shopping centre, but the opportunities are growing. Clarence Tan hopes to build and distribute the cheapest electrical car in the world. According to Tan, cheaper labour in Asia will make his electric vehicle cost 25% less than those in the US. His prototype originated from the electric three-wheeled Corbin Sparrow, first seen in the US in 2000, but which has since gone out of business.
Essentially, this car has a very low carbon footprint. Therefore, users get to save the environment. At the same time, because of these unique manufacturing techniques, this vehicle will probably be the cheapest electric car in the world.
On, you get the readings of the battery voltage, the current consumption.
Tan began selling the single-seat electric cars in Singapore ahead of the second phase of the project to make and sell a two-seater version.
Under the seat. This will be a typical charging point. This is a 20 amp industrial plug, and this is a household 13 amp plug. Made of fiberglass, is just as durable as any conventional vehicle on the road.
Tan claims his car is perfect for Singapore's urban commuter needs, despite the hefty price of $31,000. The two-seater will add air conditioning, and its drive system will also be different, allowing it to travel 100 kilometers at 100 kilometers an hour. The Renault ZE zero-emission concept has roof-mounted solar panels, green windows, thermos flask-style bodywork to keep the occupants cool or warm, and a scooter in the boot. The ZE might look experimental, but it isn't. Renault say it will appear in time for the 2012 London Olympics. The bodywork uses heat-reflective paint with a thin insulating layer to reduce heat and cold. The acid green Perspex windows act like ski goggles to protect the occupants from UV rays, keeping direct heat out of the car. Solar panels power TV screens in the dash, which replace wing mirrors. But most interesting is how Renault expects owners to keep the batteries charged. One of the biggest challenges for electric vehicles is charging time. Renault believe battery exchange is the best way forward. So instead of filling up with fuel, you'll go to a charging station where the battery will be replaced in seconds. You'll also be able to purchase different battery range lengths depending on the journeys you will make. Another Renault concept is the Twizy, which boasts a flowery exterior and a futuristic cockpit, full wheel covers, pearlescent white paint and luminous matrix displays that act as headlights and taillights, and can create smileys to tell other drivers what you think of them. An urban vehicle for city dwellers, the Twizy is 2.3 metres long and 1.1 metre wide, and carries 2 people in tandem. Power comes from a small 15 kilowatt electric motor connected to lithium-ion batteries under the seats, giving the 420 kilogram vehicle the performance of a 125cc motorbike, with a range of 100 kilometres at a top speed of 75 kilometres an hour. There are no doors, but the whole body of the Twizy acts as a safety cell, and there are side airbags. The Zoe ZE concept targets motorists who own more than one car and are looking for a compact electric vehicle capable of meeting day-to-day needs, such as the school or work run. Like most concept cars, Zoe has some odd touches. A L'Oreal button injects soothing particles into the cabin to hydrate the 4 occupants' skin, and its interior can change colour. Zoe is 4.1 metres long, rides on 21-inch wheels and is powered by a 70 kilowatt electric motor. In Renault's view of the electric car world, the driver has 3 options when it comes to filling up on energy. A standard charge takes between 4 and 8 hours via a charging socket on the outside of the vehicle. A quick charge in 20 minutes using the same socket at specific charging points. Or their exclusive quick drop system, 3 minutes at a rapid battery exchange station. Renault has put 4 electric concept vehicles on the menu in recent years, vehicles it intends to bring to full production by 2012. The company is hoping to become a world leader in EV sales, according to Chairman Carlos Ghosn. Renault boldly forecasts EVs will make up 10% of the world's market by 2020, which is way beyond other estimates. IHS Global Insight predicts EVs will account for 0.6% of total world industry volume by 2012, with another 0.7% coming from plug-in hybrids. It looks like any other small British hatchback van, but this one was converted to run on batteries. Students at the University of Southampton built the hybrid electric petrol car. While most electric vehicles have a range of about 80 kilometres, this was designed to go much further.
This car works basically as an electric vehicle, so it mainly works on electric power that comes from a battery, in this case a lithium-ion battery. Most people are worried about having not enough range with an electric vehicle, so this car has got a so-called range extender, a fuel converter, that gives you as much range as you want.
The ordinary-looking little car was targeted at developing a reliable solution for drivers who need a much bigger range than conventional electric vehicles.
The fuel consumption of this vehicle in urban areas goes up to 250 miles per gallon. That is something like 1.1 litre per 100 kilometer. And as I said, this is in urban traffic. And short distance driving or short distances make the most of all undertaken journeys. So about 90% of all journeys are shorter than something like 40 miles.
On the open road, it reached speeds of 120 kilometers an hour. It's easy to control and more environmentally friendly than petrol vehicles.
You have got no local pollution, you've got a very low energy consumption, you've got very low noise, especially in traffic jams. And other advantages are the vehicle is quite light, you can have good weight distribution because you can put the engine and the battery wherever you like. So you can use this car without power steering, and you will have a very smooth, nice driving, especially in urban areas.
After receiving his PhD, Dennis went on to found a company which uses latest battery technology in a range of applications. For example, boats, underwater vehicles, stationary engine storage, military and high-end racing cars. Hybrid vehicles save fuel, but the added cost means that they only begin to make financial sense if they're applied to luxury models, which typically attract wealthy customers for whom fuel efficiency is not all that important. Having produced 100 working examples of a hydrogen-burning dual-fuel car, BMW shifted their efforts to petrol-electric hybrids. On the 7 Series Active Hybrid, a modified 4.4-litre twin-turbo V8 engine is assisted by a 3-phase electric motor, but the car won't run on electricity alone. Unlike on smaller hybrids, the BMW's electric motor is available only to boost the V8 engine's performance. The engine gets assistance during launch and under light to moderate acceleration by a disc-shaped DC electric motor in the housing of the all-new 8-speed automatic gearbox. Thanks to those 8 gears, the car accelerates from 0 to 100 in 4.8 seconds, with a 15% saving in fuel consumption. The car does have an automatic stop-start system, which switches off the engine when the car is stationary. A brake energy regeneration system puts energy back into the battery. The car actually has 2 interconnected onboard power networks. A conventional 12-volt network for the standard car's electrical systems, and a 120-volt system for the 27-kilogram lithium-ion battery. With the Active Hybrid 7, BMW shifts focus to boosting performance. It gives customers something they can feel behind the wheel, as well as saving them at the fuel pump. Despite looking like a standard 7 Series, the Active Hybrid has a number of styling upgrades. Despite the advanced technology and modifications which add 100 kilograms to the curb weight, the driving experience is much like any other 7 Series, one of BMW's requirements. The electric motor has been engineered to complement the V8, so where the engine is lacking, for example at low revs, the electric motor is at its strongest. Further up the rev range, where the engine is strongest, there's no tangible sensation of the electric motor cutting in and out, merely a seamless surge of power. Without the central instrument display to show how the hybrid system is operating, you'd never know the engine was being helped along at all. The first few degrees of brake pedal travel engage only the regeneration system, which provides no real sense of deceleration. It's only when you push harder and the brakes are operated hydraulically that you receive proper stopping power. When that's not enough, the third stage brings serious levels of stopping power, and when required, an additional booster. As with most hybrids now finding their way onto the market, the initial sales focus with the Active Hybrid 7 is on the North American market, which is expected to account for almost 50% of total volume. Environment-conscious Switzerland hosted an environmentally friendly sports utility vehicles car show. Cadillac's 2-mode hybrid Escalade SUV is the result of a joint effort among GM, Chrysler, BMW and Mercedes-Benz. In the system, the normal auto gearbox is replaced with a pair of electric motors and several sets of gears. At low speed and load, the vehicle moves with either the electric motors, the engine, or a combination. At higher loads and speeds, the engine always runs, and the hybrid system uses ideas such as cylinder deactivation. Saab, limping from crisis to crisis as GM desperately tries to sell it, has a long history of green engineering and showed the Saab 94X Bio-Power hybrid concept car, which will use high-efficiency turbocharged engines and biofuels. Fuel economy experts John and Helen Taylor drove a 2-litre turbo-diesel Jeep Compass and Jeep Patriot from London to Berlin on less than 1 tank of fuel each. In Berlin, there was enough fuel remaining to continue the journey into Poland, covering 1,124 kilometres with a passenger and their luggage. The star of the show is a Rinspeed Scuba from Switzerland, the world's first underwater car, inspired by the submersible car from the James Bond film The Spy Who Loved Me. Scuba can submerge to a depth of 10 metres and has no roof, so both driver and passenger will be scuba diving during their spin underwater. It flies when underwater like a submarine, as it's not designed to travel along the seabed. The car's top land speed is 120 km an hour. On the water's surface, top speed is 6 km an hour, and underwater it's 3 km an hour. The Ford Airstream is a retro-futuristic crossover SUV that was inspired by the classic Airstream caravans and trailers built since the 1930s. 12 ceremonial rivets pay homage to Airstream's iconic construction. Much like Ford, Airstream began with one man's dream. In 1931, Wally Byam began using aircraft construction methods to make trailers aimed at feeding Americans' surging desire to travel. Both companies are influenced by economic and demographic trends. sections and in a number of different window configurations. Interestingly, all will be built in Turkey as 2 passenger window vans and converted into other forms once they arrive in their destination countries. And what is the prospect for a car which doesn't need a driver, a car which can steer itself? The technology exists. Highly accurate satellite navigation, digital cameras that can see night or day, and thanks to DARPA, the Defense Advanced Research Projects Agency competition sponsored by the US Department of Defense, the driverless car is a reality. Cumbersome it may be, but the system is in its infancy.
The actuators of steering, braking, gear shift and acceleration are a mixture of mechanical and electronical components that are effectively controlled by a computer that's in the trunk of the car, and another processing system that takes data from the sensors, knows what's around the car, if there is an obstacle in front, so you should drive around, and then tells this system which path to take at what speed, and so it sets the vehicle parameter.
It has a normal PC that reads scanned data, a route network that tells it roughly where the streets are, and then it uses its sensors to detect where the curbs are, where the white line is, and then stay in its lane. There are 3 laser scanners, 1 in the rear fender and 2 in the front, and the GPS is on the roof. They've been specially developed for the vehicle. The immediate future for the car's technology is for safety.
Right now there will be spin-offs that will enhance safety, like you would want any car to avoid an obstacle that could be both some other vehicle, it could be some other person that is standing in front of your car. You wouldn't want your car to injure those persons, and that will be one of the immediate spin-offs of this project.
Built with the driver in mind, Volvo has packed the latest in high-tech into their $10 million concept car, the SCC2, giving a glimpse into their view of the future of driving.
If you know where the driver is sitting, you can design the car from that position, meaning that if you have your eyes here, you can design everything that he sees as good as possible out of the car, but also in the car.
Sensors and cameras in door mirrors and bumpers eliminate blind spots and warn of potential collisions. An adaptive lighting system monitors speed and steering movements with a built-in infrared camera improving night driving. Though the SCC2 probably won't go into production, many of its life-saving features will. Nissan's battery-powered Pivo 2 concept car is aimed at drivers who aren't good at reversing or parking. It can rotate its cabin through 360 degrees and can turn its wheels through 90 degrees, allowing the car to maneuver sideways and making it easy to parallel park. Pivo 2 also has a dash-mounted robot which can conduct a daily conversation in Japanese or English with the driver.
With this easy-to-handle car, you can feel comfortable while driving. You can go everywhere without worrying about your driving skills.
Beyond what we've already seen, what does the future hold for the amazing world of the automobile? Will driverless cars one day whisk us to our destinations as we sip tea and scan the newspaper? Will cars fly? Will alternative energy sources make petrol stations redundant? Will car crashes become a thing of the past? In reality, the answer to all these questions is probably no. Cars won't fly, crashes will still happen, and petrol stations will still exist. Perhaps fewer and further apart, but the internal combustion engine is far from down and out. And for those with grease under their fingernails and a love of all things mechanical, this is likely a good thing.